Hello everyone, this is our fifth educational based video. In the previous video we have seen about what are the types of supports, what are the types of beams and what are the types of loadings. In this video we are going to see about support reactions. We have to learn how to find out support reactions on a beam. So before starting with the video, please do like, share and subscribe to our YouTube channel, and please press the bell icon so that you will get all our upcoming videos. Now, this particular topic is very much important for the engineering students who are doing degree and diploma for the subject like engineering mechanics, then theory of structures, you can call it as TOS, or there is one more subject, MOS. So basically I have divided this model into four parts, that is simply supported beam, cantilever beam, overhang beam with internal hinge, and last one I have done is continuous beam with bracket load. So very first part is simply supported beam. Simply supported beam means one will be hinge support and one will be a roller support. So this is my simply supported beam. You can have a look at. This is point A. I am having UDL of 10 kN for 4 meter span, then 5 kN. It will be at total 4 plus 2, that is 6 meter, and then there is 1.5 meter gap. So total you have span is 4 plus 2 6 plus 1.5, that is 7.5. So particularly let me just name this point as point D. Okay, now to find out support reaction, what we will be doing is summation Fy equal to 0. That means addition of all the vertical forces coming on the beam equal to 0, and I'll take upward loads as positive, downward as negative. So Ra and Rb both are upward, so I'm taking positive them. Then this 10 into 4. I have explained in the previous video how to find out equivalent load for a UDL. So this 10 is the intensity and 4 is the span. So 10 into 4, as because it is a downward load, so minus 10 into 4, and again this point load is also downward, so minus 5, you get an equation. Let's just number it as equation number 1. Now to find out summation either of the point, I'll take moments equal to 0. Okay, so I'm taking summation moment at equal to 0, and I'm taking clockwise moment positive. This is my assumption. You can take even anti-clockwise also positive. So I'm here taking clockwise moment positive. Now again this also I have explained how to find out the moment for a UDL. So 10 is the intensity, 4 is the span, and it will be exactly distributed at the midpoints of 4 by 2. So it will be 10 into 4 into 4 by 2. Then this 5 meter is at 4 plus 2 6 meter distance, so plus 5 into 6, minus this Rb is going anti-clockwise, this both were positive, and this is going anti-clockwise, so minus Rb into I am doing 7.5, total length is 7.5 equal to 0. So when I solve this equation, I am getting value of Rb as 14.67, and my answer does not changes sign, like it is only positive, so whatever direction I have assumed is correct, that is upward. And when you put this value in equation number 1, get Ra, that is value is 30.33 kN. Again I am not getting any change in sign, so the assumed direction is correct, that is upward. So this is how to find out support reactions for a simply supported beam. Now let's see how to find out support reactions for a cantilever beam. I have explained in the previous video what is cantilever beam. It is fixed at one end and it is hanging at the other end, it is free at the other end. So here I am having a cantilever beam of span total 5 meters, and at free end I am having a downward point load of 4 kN. Now as because it is a fixed support, so I have three unknowns obviously, that is vertical, horizontal and moment. Here also I have written HA equal to 0 because there is no horizontal load coming on the beam. Similarly here also there is no horizontal load, so I am having HA equal to 0. If you have any horizontal load or inclined load, then you have to get a horizontal load as well. That means you will have some value over there. So for this again I am taking summation Fy equal to 0, upward positive, so Ra upward and 4 is downward. That way I will get Ra equal to 4 kN upward arrow. Then when I do summation Fx equal to 0, I would get, as because there is no horizontal load, so HA equal to 0. Then I have summation moment at A equal to 0, I am taking clockwise moment positive. So as because I have assumed this is anti-clockwise, that is why I am taking a negative sign, and this 4 is going clockwise, so plus 4 into distance is 5, so that way I am getting value of MA as 20 kilonewton meters. Okay, now this is all about to find out cantilever beam support reactions. Now third part is to find out support reactions of a overhang beam. Okay, so to find out support reaction of overhang beam with internal hinge, what I have is, this is my overhang beam wherein I have hinge support at A, roller support at B. In between there is, exactly at the center, I have moment, anti-clockwise moment of 6 kilonewton meters at point F. Then I have a UVL. What is UVL? That also I have explained in the previous video, of intensity 10 kilonewton per meter distributed over 4 meter span. Then at point C I have an internal hinge. This 1 meter has no load. Then this D point I have again a roller support. Sorry, I have marked it as hinge support. It is not hinge, it is roller support I am assuming. Okay. So again at the free end I have 8 kilonewton downward load, and this distance is again 1 meter. So my unknowns are RA, RB, as because again there is no horizontal load, so HA equal to 0. Then RD, 3 unknowns I have. So what I am doing is I am taking summation vertical forces, that is Fy equal to 0, upward positive. So this RA, RB, RD, all 3 are upward, so I am giving positive sign to them. Then to find out this triangular load, or you can call it as UVL, that is uniformly varying load, how to solve this I have explained in the previous video. As I'm again and again repeating, so you can look at previous video. So this is triangular load, so half into base into height. My base is 4 and height is 10. So this is, and as because this is a downward load, so it is minus half into 10 into 4. Half into 10 is my height of the UVL and 4 meter is the span. And then again I have a downward load of 8, so minus 8 equal to 0. I get an equation, I'll just name it as equation number 1. Again I said there is no horizontal load, so I get summation of x equal to 0. In a direction I'm assuming, let's say I'm assuming right direction positive, there is no use over here because there is no horizontal load, so HA equal to 0. Now my third part is to do, now as because C is an internal hinge, see we have taken C is an internal hinge, so I have to take first part, I'll take summation moment at C left part equal to 0, and then I'll take summation moment at C right part equal to 0. So this is the thing what I have, summation moment at C left part equal to 0. So in the left part what I have is RA going clockwise, so RA into 8, this distance is 8, so I have RA into 8. Then I have anti-clockwise moment of 6 kilonewton meters, so minus 6, I've written here minus 6. Then I have RB again going clockwise, so RB into 4 I have written, RB into 4. Then UVL, so this UVL half into base into height, so half into base is 4, height is 10, and it is exactly 1/3 from right angle and 2/3 from other end. So this is my other end, so 2/3 of 4. So same way I have written here, let's have a look, half into 10 into 4 into 2/3 of 4 equal to 0. When I do that, what I get is this equation, 8RA plus 4RB equal to 59.33, equation number 2. Then I'll take summation moment at C right part equal to 0. Okay, so at right of C I have only two things, that is my RD unknown and I have 8. Now RD is going anti-clockwise and 8 is going clockwise, so that is why this RD, see RD into 1 because it was going anti-clockwise, so minus, and it is going clockwise, so plus 8 into 2. See, 8 into 2 and RD into 1 about C. So this way I'll get the answer of my RD unknown, and when I put this value in the equation number 1, I get another equation, that is RA plus RB equal to 12. Let's say this is my third equation. Now when I solve these two equations simultaneously, either by solving manually or you can get it on your scientific calculator as well, or any calculator as well, any in the sense like there are lot many types of scientific calculators like MS, ES and all, so you can get these values of RA and RB. Okay, Now students, let's move on to our fourth part, that is continuous beam with bracket load. Okay, so this is the beam. Just have a look at, see, this is my fixed support. So there are three unknowns, 2 meter span. Then at B point I have a bracket. How to convert this bracket, as also I have explained in the previous video. In this video also I am going to explain about this. So this bracket is at 0.2 meter distance up to B. The load of bracket is 1 kilonewton. B to C, there is no load, but at C there is an internal hinge. Then C to E, at D point is an inclined load of 10 kilonewton at 45 degrees in this direction. This total length is 6 meter, and I have shown equivalency, so this is exactly at the middle, and this is point E. At point E I have a roller support, so there will be only one unknown. Now this conversion, that is inclined load, it will be distributed as horizontal as cos component, that is 10 cos 45, and vertical as sine component, that is 10 sine 45. And this bracket generates two types of loads, that is one will be a vertical downward load of 1 kilonewton, exact the same value, and then it will give a clockwise moment of 1 into 0.2, that is again 0.2 kilonewton meters. So this way I'll just give you a look, see. Okay, now summation Fy equal to 0 I am doing. So for summation Fy equal to 0, I have Ra plus I have Re, both are upward, I am taking upward positive. Then minus 1 of this load. Moment you should not consider in while calculating the support, the summation Fy equal to 0 or summation Fx equal to 0, because herein we are taking only the loads or the forces coming on the beam. Okay, no, not load, sorry, the forces coming on the beam. Then there is one more load, this is downward load, so minus 10 sine 45. So I get an equation. Then again same way as we did in the previous numerical, summation moment at C left equal to 0. I am assuming anti-clockwise direction for MA, so minus MA. Then about C I have one more load, that is Ra into 4 plus 2, that is 6. Then again this load, that is 1 into 4 going anti-clockwise, so this load, see, 1 was at B, so 1 into 4 going anti-clockwise, so minus, and then this moment 0.2 plus equal to 0, so I get another equation. When I do summation moment at C, right equal to 0, what are the things I have at right side? I have only two things, that is my 10 sine 45 I have, and then I have Re. So Re is going anti-clockwise, so minus Re into 6, this distance is 6. Then I have this load going clockwise, so plus 10 sine 45 into the distance is exactly half, so 6 by 2, that is 3. So I get value of Re. Then from equation 1, when I put the value over here, I am getting value of Ra. Then last thing what I have to do is summation moment at A equal to 0. Last, because this is the like horizontal, finding horizontal reaction is not that tough, even nothing is tough over here. So summation moment at A equal to 0 when I take, so MA I have to obviously consider, so anti-clockwise minus, I am taking clockwise positive again. Then this 1, this going clockwise, so 1 into distances, this 1 is at, see, you can notice this 1 kilonewton load is at point B, so 1 into 2, so this is 1 into 2. Okay, then this moment 0.2, this is a moment, so it is going clockwise, don't have to take any distance for that. Then this 10 sine 45 going again clockwise, so 10 sine 45 as our distance 4 plus 2, 6, and is half. Sorry, I did, yeah, so this is 10 sine 45 into 9 minus 3.54, that is my Re, into, see, this is my diagram, I'll give you a proper look. So this is 10 sine 45, as because going clockwise, so I'm taking it as positive into the distance 4 plus 2 6, and half is 3, so total is 9 minus 3.54, that is my Re going anti-clockwise, so minus 3.54 into the total distance is 12 equal to 0. When I solve this, I get a value of MA, and when I put this in this equation, I get value of Ra. Now to find out the last reaction, that is horizontal reaction, I'm taking summation of x equal to 0, that is forces going in x direction equal to 0, and I'm taking right positive, so HA going right, so positive, and then this 10 cos 45 going left, so negative equal to 0, so that's why I get HA equal to 7.07. So guys, this is all about today's video, how to find out support reactions for the different beams having different types of, you can say, supports or different types of loadings on the beam. In the next video we will see about how to find out SFD BMD or maybe something else. So stay tuned with our channel, and please do like, share and subscribe to our YouTube channel. Thank you so much guys. Bye. See you in next video.